Bismillahirrahmanirrahim. Assalamualaikum and very good day to you all. In this video, we are talking about chapter 11.6, combined radial and transloading. Okay, this content is taken from the chapter 11 from the Shigley Mechanical Engineering Design book, and the images here is taken from the book itself and also from Google Images. Okay, let's start. So what is a radial load and transload in bearing? Okay, so let me explain what is a radial load and transload. Okay, so basically with the bearing is circular in nature. Circular. Okay, okay, they have the outer layer, they have the outer ring. This is the inner ring. Okay, both are rotate, both can rotate. Okay, when you put the shaft inside the inner ring, and the shaft rotate, the shaft will rotate in the ring. There will be different calculation for it. And when the outer ring rotate and inner ring does not rotate, there will be another equation for it. Okay, this is I will explain in the text. Okay, so when it rotate, it will have the radial load. Okay, with the radial load we contribute because of the weight of the shaft itself. Also, okay, also weight of the bearing itself, which is bearing is not that heavy. Okay, and the thrust load is where the bearing is like thrust is loosely translated that you give a force. It's like an axial load, but thrust load is given force to make you fall down. This is for the thrust load. Loosely interpretation of thrust load. You can find thrust load definition, better definition in Google. Okay, so ball bearing is capable of resisting radial load and thrust loading. Furthermore, it can be combined. It can be combined radial load and thrust load. Okay, consider FA. A equals to axial load. And FR, no, A is equal to axial thrust. Okay, you can see here the evaluation that they use. If A equal to axial thrust, FR equal to radial load. Okay, both the unit are Newton for force. Okay, uh, and Fe is the equivalent. Both Fe equals to Fa plus Fr. You get the Fe, okay, equivalent load. And then the rotation factor V is defined as such. B equals to 1 when inner ring rotate, okay, and V equals to 1.2 when outer ring rotate. Remember I tell you that bearing have inner and outer. So V equals to 1 for inner and V equals to 1.2 for outer ring. Okay, so two-dimensional group can be formed by equivalent Fe equal to V. Okay, you can see here two-dimensional load because the load cancel it out itself. So Fe equals to V rotational factor, F R equals to 1. Okay, when Fe V F R equals to E up kisar. Okay, you will I will explain in the next slide. Okay, so Fe equals to V F R equals to X plus Y Fa equals over V F R when it is over the up kisar. Okay, let's see the next slide. What is an up kisar? Okay, you see in the figure here, this figure 11.6 shows the value what is mean by up kisar. Okay, there is a graph, a logarithmic graph, plotting for this, okay, this is the Abkisar E, okay, this is the slope X and Y, okay, this is X, this is Y, okay, this is FE equal to VFR, this is FE equal to VFR, so you can get this slope, okay, X is the coordinate of intercept and Y is the slope of the line for this equation, okay, this equation is we explain, but actually in practice you will use the table 11.11.1 is the next slide, okay, we will show you in the next slide, uh, but this table will explain how the table you get the table, okay. It's common to express figure 11.1 as a single equation Fe equals to x1 Fv Fr plus yi Fa. Remember, x is the slope, s is the x-axis, y is the y-axis, v is the rotation factor. For inner ring is equal to 1, for outer ring equal to 1.2, and uh, and uh, Fr, Fe, Fr is the radial load, Fe is the axial thrust. Okay, so the basic static load rating in the load will produce the total permanent deformation in the railway, in the raceway and the rolling. I will explain what is the basic static load in the next slide. Okay, let's see here the table 11.1 equivalent radial load factors for uh, ball bearing. Remember, ball bearing, not taper bearing, ball bearing. Okay, ball bearing. Okay, okay. So this is the table 11.1 where you will do the calculation in the last slide. You will do the calculation. You see here, this is the approximate value. This is the Abkisar value. This is the FA as a thrust over catalog rating CO. Remember, CO is the catalog rating. Let's say when just like when you go to the supermarket, you want to buy something, you see the supermarket have the catalog, you see you want to buy vegetable, you want to buy fish, you want to buy chicken, okay, they have the catalog. The same also goes for the bearing itself, they also have the catalog. The catalog given is a catalog rating. You need is Newton force, meaning the force for the bearing you want to the bearing can support how many force, okay. And this is the Abkisar value. You can see here for the value uh, for below Abkisar, it is uh, 1 and 0, and after Abkisar value it will be have the value, and this y2 also have the value, okay. See in the next slide, basic static loading. What is the mean by basic static loading? Is the load that will produce a total permanent deformation in the raceway in the rolling element of any contact. Okay, 0.001 times the diameter. It's safe to say that when the bearing, uh, you you don't put anything load on it, okay, uh, no, you put load on it, not moving yet, it's not moving yet, it is called the basic static loading, okay. Is when you put the shaft is not moving yet, okay. This is the basic static loading, whether the load can support or not, okay. So uh, table 11.2 dimension and load rating for single row, deep groove and angular contact ball bearing. Remember, ball bearing, they have single row and double row. Okay, single row and double row. Okay, this is single row and double row have double the ball for the bearing. Okay, so remember in this equation it give uh, the value for the fillet radius, width, shoulder diameter and something. This is what they call by dimension of the bearing. When you find when you want to acquire the bearing, okay, then you get this, then you get the certain value for the bearing, and then you know this is dimension. You must design your shaft and all attachment that will attach to the bearing is suitable with the bearing requirement. Okay, because the bearing come from the factory, you don't design the bearing yourself. Okay, you get what they give and you design accordingly, like meaning by the width, the shoulder diameter, the deep groove, the load rating and everything. This is what dimension that you have to design yourself. Okay, to suit for the bearing. Okay, this is the rotation factor. Rotation factor is intended to correct the rotating ring condition. The rotation factor of 1.2 for outer ring. Okay, is simply as an acknowledgement for the fatigue life is reduced under this condition. Self-aligning bearing exception, we have V equals to 1 for rotation of either ring. This rate or cylindrical roller bearing will take no axial load. Operator, the Y factor is always 0. This is explained. Can when you can pause back this video and you go back to the slide on table 11.1, you can see Y is 0 before Kisar. Okay, why is that happen? This is the explanation. Because it will take no axial load. Okay, no axial load. That is why becomes 0. Okay, that is explained for table 11.1. Okay, and then boundary dimension for bearings. The ABMA, Association Bearing Manufacturers America, okay, standard has established boundary of dimension for bearing, which defined as define the bearing bore, the outer diameter, the width, the fillet size, and the shaft and the housing. Meaning that you can read all the statement. Meaning that when, as I already said, the bearing come from the company, you have to design your thing accordingly. Okay, you can have to design the shaft to make it can fit to the bearing, not the bearing fit you. You have to fit to the bearing. Okay, this is why the challenges for engineers like you all to decide what the bearing is suitable for you. Okay, because the bearing come from the factory, you have to design your part according to the bearing size. Okay, so let's go to the next slide. Okay, this is the basic ABMA plan. Okay, plan for boundary dimension. This apply to ball bearing, straight roller bearing, spherical roller bearing, not to each roller bearing or tapered roller bearing. Okay, in series the contour or the corner is not specified. It may be rounded or chamfered, or it may be small enough to clear the fillet radius specified in the standard. Okay, so this is the basic ABMA plan. Okay, this is how you know the series. You can study this. Okay, the bearing identified by two-digit number called dimension series code. The first number is the code with width series 0, 1, 2, 3, 4, 5, and 6. The second number is from the diameter series outside 8, 9, 10, 11, 11 and everything. Figure 11.7, okay, shows the variety of bearings may be obtained for particular bore. Since the dimension series code does not reveal dimension directly, necessary to resort to tabulation. Okay, see table 11.2. You can pause, you can go back to table 11.2. Better still, if you have the textbook, you can see what the slides mean. Okay, basically this is the bore, this is the bearing. Okay, this is the bearing, this is the bore that you put the shaft inside the bearing. Okay, and this is the bore that you put the shaft inside the bearing. And when you can see it in this position, okay, you can see in this position, this is the bore. Okay, where you put the, this is the bore where you put the shaft inside it. Okay, and then this is the dimension series 0, 0. Okay, and then this is the height, the thickness of the bearing itself, whether you want big or not, big or not big. This is how you read. This is how you identify which bearing that you want. Okay, you can study this. Okay, housing and shoulder. The housing and shaft shoulder, this table should be used whenever possible to secure support for bearing and to resist maximum thrust load. Okay, figure 11.3 lists the dimension and load rating of some straight roller bearing. Okay, so you can see here, as we discussed before in the video for chapter shaft. Okay, on the chapter shaft, yes. Also in the chapter screw, the function of shoulder is to provide resistance for vibration. Okay, if that don't have shoulder, yes, this is the one. Okay, this is a cylinder. Okay, this is a cardboard. Let's say this is a cylinder. I give vibration here, it vibrate. Okay, it will vibrate until it come to the shoulder, and the shoulder will stop vibration at the shoulder, okay. And this is how you stop on all the vibration. So for the, if you can remember the shaft chapter, they have, you learn about shoulder. Okay, this is called the shoulder. Okay, whenever vibration, okay, it will stop at the shoulder. This is why shoulder is important. Okay. Okay, the dimension and basic table 11.3 shows the dimension and basic load rating for cylindrical roller bearing. Okay, in the previous slide we are talking about ball bearing. Now we're talking about cylindrical roller bearing. This kind of bearing, this kind of thing. Okay, cylindrical. So this is 02 series, this is 03 series. Again, they have the diameter, such as the diameter such as before. You have to uh, you have to design your shaft according to the this design. Okay, according to the dimension given by the manufacturer. And then to assist the designer in selection of bearing, most of manufacturers handbook contain data on bearing life or for many class of machinery as well as information on load application factor. We will learn about load application factor in the next slide. Okay, such information has been accumulated in the hard way. This is by experience, and the beginner designer should utilize this information until he or she gains enough information to, when the measures are possible. Okay, so the bearing, the knowledge of bearing have been in a long time ago, back in since the beginning of the industrial revolution in the 18th, okay, 1800. Okay, we don't live yet that time. Okay, so those back in those generation, long ago generation, they have learned from hard way. Okay, they have learned from experience. They have learned from experience. This what the witnesses they have learned, and then as the generation goes by, come our generation, they already have all the experience they get. They have the handbook. Okay, meaning that when you are working, just ask your senior technicians, just ask your senior engineer, uh, how they solve this problem. Okay, they should have the handbook, or they may know by their experience. They can tell you. Okay. So you have this also. They have the textbook. You also have the guideline book, and then better still, you should ask senior engineer, senior technician, how to handle the bearing, and they can tell you from the experience how to handle the bearing. Okay, how to service the bearing and everything. Okay, so this is the bearing life recommendation for typical. Okay. So you can see here the very life recommendation for various class of machinery, for aircraft, for instrument, in frequent use. This is called the kilo hours. Uh, Basically, if you divide this hour to 24 hours, you can estimate how many years this can function. Okay, you can see here for continuous 24-hour service, 60,000 hours for the continuous reliability is extremely important. 200 hours, meaning that you just imagine for power turbine, for hydroelectric dam, they have the turbine and everything. That thing theoretically should last forever. Okay, because how can you do the maintenance for that, and then all the electricity must be stopped, and it's not possible, and it's not. For example, hydroelectric dam, you if you do the maintenance, no electric for certain period of time, so very headache, very headache for people, if you do like that. So that is why some bearing life will be last forever. Okay, for most application that we see in everyday usage, it's not for the lifetime. It have the period. Okay, have the lifetime period of time. Okay, so this is the bearing life recommendation. Okay, and this is the load application factor, meaning that the word AF. Okay, after this, when we are doing some calculation, we will know the word AF. Okay, AF equals to what? AF equal to 1, AF equal to 2, 3, 4, and 5, and everything. So this is the recommended value for AF. Okay, precision gearing, commercial gearing, poor sealing seal, no impact, light impact, moderate impact, and much more. Okay. Okay, now let's go for the example. This example is a short example. Hopefully you can understand. Okay. And HKF 6210 angular contact ball bearing as a load FA, also called as a thrust. Okay, is 400 pound, and radial load FR 500 pound applied to the outer ring. Remember, outer ring, inner ring, outer ring, and inner ring. Okay, because the difference is V equals to 1.2 for outer ring, and V equals to 1 for inner ring. So basic static load rating is 4450 pound, and basic load rating C10 is 7,900 pound, meaning that when the bearing in static condition, it can support 4,000 pound. Bearing uh, in load rotation, it can support to 7,900 pound. Estimate the life of a speed of 720 revolution per minute, meaning that you can estimate when you have to do the maintenance for this certain this ball bearing. Okay, okay, how to do this question? Okay, you see here, V1 equals to 1 for, obviously, for inner ring. Okay, so FA equal to C naught equals to 0.09. Interpolate table E in table 11.1. You pause this video, you go back to the video that shows table 11.1, you extrapolate. Okay, if the data is not there, better refer for the textbook, because I only cut little bit of the picture, little bit of table 11.1, put in the slide. Okay, if you have the textbook, better. Okay, you can see the value E is in the mid. The value E, you can see 0.084, 0.011. No value for 0.09. Okay, in the table 0.084, 0.110. Okay, this is in the table. Okay, 0.09 is not in the table. You have to extrapolate. Okay, you have to make an assumption. Okay, where E equals to 0.285. Extrapolate the graph. Okay, you can see where the value. Okay, and then again you put this value FA equal to 0.08 more than 0.285. Interpolate for Y, you can get this value. Again, it is not in the graph. It is not in the graph. You have to extrapolate the graph. Okay, which if any answer in between, as long as the answer is in between, is okay. Okay, you may have your interpretation may have 0.29, or for Y2 you may have 4.6, 4.55. It's okay, as long as it is within the range. Okay, so FE equal to, you can put in all this in equation value, you can get 890, and then put in 890 pound for equivalent load, and then you put the answer in this, then you get 16,000 hour. And then what does that mean by 16,000 hour? You divide by 24 hours per day, and this is the time, and then what the time that you get, you should do maintenance after that or before that time came. Let's say 16,000 hours equivalent to 1 year. Let's say before 1 year come, you should do the maintenance, maybe changing the bearing, do the proper lubrication and everything to make it's longer time. So uh, that's all for the video. For this video, it's a lengthy video, 35 minutes. I hope you understand. I hope you understand. So that's all for the next video. We see you in the next video. We talk about variable loading. Thank you very much.